strategy for this problem is exactly the same as the previous problem that I did. We've got manganese hydroxide, and this of course is solid in an equilibrium setting. It dissociates to form manganese cation plus 2 molar equivalents of hydroxide anion. To solve this problem, we're of course going to have to do an ice table. As we've done before, at initiation for one of these things, I just set the concentration of this thing to be 1 and these things to be 0. That is, right at initiation, when I take my manganese hydroxide and chuck it into water, it's 100% manganese hydroxide right at the beginning. That's before any dissociation has occurred. So, by what amount is there going to be a change here, here, and here? Well, it gives me the molar solubility, and that number ends up going right into here. So what you do is you find one of the things on the right side of the equation that has a 1 in front of it as a coefficient, and that's where the molar solubility goes. So I've got 2.2 times 10 to the negative 5th molar. I also have the same molar solubility for this thing, 2.2 times 10 to the negative 5th molar, but I have to multiply it by 2 because there are 2 molar equivalents. Now, by extension, the amount of manganese hydroxide molarly, I'm not sure if that's a word, is going to decrease by that same amount, minus 2.2 times 10 to the negative 5th. The final answer for these equilibrium settings is going to be made by just adding row 1 to row 2. So 1 minus 2.2 times 10 to the negative 5th there, and then 0 plus this amount, 2.2 times 10 to the negative 5th, and then 2 multiplied by that is going to be 4.4 times 10 to the negative 5th molar. These are the amounts for each of these things at equilibrium. Now, I'm going to write down my KSP. My KSP expression is going to be equal to the concentration of the ions on the right side of the equation. And of course, because I've got a 2 in front of the hydroxide, I have to square that in the KSP expression. You'll notice once again that because this item is a solid, it does not appear in the KSP anywhere. So all I have to do is take these values and throw them in for the corresponding places here. So manganese cation concentration equilibrium goes right there. I multiply it by the hydroxide ion concentration of 4.4 times 10 to the negative 5th. And I have to square that term. You throw that into your calculator, that will give you the final KSP for this equilibrium setting.